So for Algebra 1 in Unit 2, when we're solving linear problem solving, or we're solving linear word problems, the big thing is that you can set it up any way that you really want to. So if we look at number 1, I'll explain what I really mean by this. So the store at which Andy usually shops is having a sale. Roast beef costs $4 a pound and shrimp costs $10 a pound. Write an equation to describe different possible combinations of roast beef, not beef, and shrimp that he can buy for $96. So you can think about it as, and you can write these types of things out and say like independent variable, dependent variable, or just saying X equals Y equals so that you don't get confused. So I'm going to say X is roast beef, which makes Y shrimp. Okay, what is the given information in this problem? All right, so you can always think about, all right, am I given the slope? Am I given a point? Am I given, the total amount, the y-intercept, anything? So we don't have a y-intercept. We don't really have slope. Remember, this is going to say like the word curve or something like that, right? We do have a total of $96, and we do have a point technically of 4 pounds of roast beef, and then $4 a pound of roast beef, and the shrimp is 10. Okay, so we can write an equation to model this situation. And you could do this a couple different ways. So you can either write this as more of like a point slope type thing, or because we don't have the slope, we can think about it in standard form, right? Because here's something that goes with x and y, and then here's our total, right? So our equation would be something like 4x plus 10y equals 96. Because what is the greatest amount of shrimp you can buy, right? So obviously he wants to buy a little bit of each, and um, shrimp is talking about twice, right? So actually, it doesn't tell me that I have to buy some of each. So in reality, what it's asking is if I buy no roast beef, how much shrimp can I buy, right? So in reality, we're looking at 10y equals 96, right? Because we could have 0 of the other one. So if we solve for y, we can say that he would then be able to do 9.6 pounds if he wanted to. Remember, with word problems, you always have to label it. We're getting away from labeling all those things, but it might be something that can help you. So if you feel like it's something that can, please feel free to do so. Pick 'em Up Towing Company charges $40 to hook a car, and then $1.70 for each mile. Okay, so for each mile is kind of the same thing as per mile, right? That is towed. Write a linear equation that represents the total cost C for the car that is towed M miles. Then determine the total cost for towing 17 miles. So this one is specific on how you want it to be written. So C is the total cost. Okay, and like we said, $70 per mile, right, is talking about slope. So 1.70 per mile, which normally we would have an X here, but we're using M because it says for miles. And it has an original cost of $40. So in reality, this is your y-intercept, and this is your slope, which is why we wrote the equation that we did. So here's my equation, but we need to talk about what it costs to do 17 miles, right? So if we're going to tow it 17 miles, that means that we are going to plug in 17 for M. And if we take 17 times 1.7, we get 28.9. And if we add that to 40, we end up getting $68.90. As long as you put the dollars on it, I'm okay. You can say, is the cost after towing a car 17 miles, but I'm okay with just writing that. Number 4, between 2002 and 2009, you added approximately 21 stamps per year to your collection. In 2007, we had 109 stamps. Find an equation that represents the number of stamps in your collection since 2000. Then use your equation to find the number of stamps in your collection in 2009. So again, we have something per year. So this is talking about your slope. And 2007, 109 is really talking about a point, right? So our M is 21. And our point, you can look at this a couple different ways. I would just write it as 2007, 109. Okay, so we have a point, we have a slope. So let's go ahead and put it in point slope form. Y minus our y1 equals our slope times x minus our x1. Now we can use that as our equation. And it says, and then use your equation to find the number of stamps in 2009. Well, 2009 is a year, and we used years as our x values. So we can plug in 2009 for x. So y minus 109 equals 21 times our new x, which is 2009, minus 2007. Again, order of operations, we need to do the parentheses first, and we get 2. So if we multiply that by 21, we get 42. And then all we have to do is add 109 over. And if you add 109 to 42, we get 151. Okay, now again, we need to figure out what that means. We would have 151 stamps in our collection. For number 5, the cost for 7 dance lessons is $82. Again, that can be looked at as a point. The cost for 11 dance lessons is $120. 11, 20. Write a linear equation to find the total cost C for L lessons. Then use the equation to find the number of lessons if the cost was $52. So obviously, we're going to have to find slope. Anytime we have points, we find slope first. So change in y over change in x. So we have 122 minus 82 over 11 minus 7. In reality, this gives us 40 over 4, which is 10. So my slope is 10, and I need to come up with an equation. So normally this would be y minus y1. Now I'm going to use 7 and 82 equals our slope times x minus our x1. Now again, this one was specific. We need to use C for cost and L for lessons, right? So let's go ahead and solve for y, and then we can replace it with those letters. So 10x will, or minus 70, add 82, and y would equal 10x plus 12. Because they want C for total cost and L for lessons, we just replace it here. Now I wrote L a little different so that I don't get confused that it's just 101. Now it asks to use the equation to find the number of lessons cost of $52. So that means we would say 52 equals 10L plus 12, and we would solve for 10, or sorry, solve for L. Subtract 12, and we get 40 equals 10L, which would obviously make L 4 if we divide by 10. Mr. Jones receives $3,000 annual salary. Receives a $3,000 annual salary increase on the anniversary of his hiring if he receives a satisfactory performance review. His starting salary was $41,250. Write an equation to show J, Mr. Jones, his salary after Y years at a company if his performance reviews are always satisfactory. Then use the equation to find the salary after 5 years in the company. So this is an annual salary, which means this is the whole per year, right? So this is your slope. And obviously this is your y-intercept, right? That's where you start. So if we write this out, we would have J, because that is Mr. Jones's salary, equals the slope, which is 3,000, plus 41,250, because that's where he starts. Oh, sorry. We should have this as y, because it says y is after y years. So now it says, let's find the salary after 5 years. So we're going to plug in 5 to our equation. Which means our salary would be 15,000 plus 41,250, which would give me $56,250. At age 12, Patrick weighed 43 kilograms. So here's a nice little point for it. At age 14, he weighed 50. Patrick's age and weight are related. Find a linear equation relating Patrick's weight to his age. Use your equation to find out Patrick's age when he weighed 36 kilograms. So, like always, we have 2 points. Let's find the slope. So we have 50 minus 43 over 14 minus 12. That gives us 7 over 2, which can't reduce. At this point slope, y minus 43 equals our slope times x minus 12. You can leave the equation like that, but I would start solving for y. So we have 7/2 x minus, that would give me 6 times 7, which is 42. All we have to do is add 43, and our equation is 7/2 x plus 1. Now they want us to use the equation for when he weighed 36. Weight is actually your y, so we're going to plug that in for y. Solve for x, we would subtract 1. And then to get rid of 7/2, we would multiply each side by 2. When we do that, we get 5. I wrote that one. This one is 7. Let me try that again. This is not 5. This would be a 10. So he